How are you? Are you ready for today? I think we have today, you know, Maykhel De Leon. That's good. He's a head of product development.
That's right.
Managing a very good team of IT and data science. Has a good experience. I think what the idea is, as always, is to try to share ideas and thinking about how big data is transforming today's business and business model. Maykhel, it's your turn. Yes, but you will have to speak with the mic.
Sure.
Thank you.
Sure. Thank you very much, Dr. Rodrigo. Okay. Hello, everyone. Good evening. Well, yeah, first of all, thank you for having us in this session. So I believe this is the second session that you're having with, in partnership with Shira, of course. So today I'm gonna talk about big data. So anyone familiar with the term big data? What is it about? Anyone? All right. Okay, so basically we're gonna tackle all the challenges that we might face as an organization or as an individual who deals with big data, right? So we're gonna talk about the challenges, how we can overcome those challenges, and how we can actually deliver an actionable insights within our organization. So a little bit about our company. So our company is called AHB.ai. So it stands for Maykhel.ai. So we are a joint venture company located at the park, Sharjah Research Technology and Innovation Park. We just became operational this year, early this year. And what we are mainly is we are a product development company which focuses on development of AI technologies. So we deal, in terms of AI domains, we do loads of work around large language models, computer visions, predictive models as well, and other deep learning stuff. And also we have a high performance compute data center in Sharjah, the park. So if you're familiar with the term, HPC is a hardware or a data center specialized for AI workloads, right? So it's a different types of data center from traditional data centers that we have for normal IT infrastructure. So it has GPUs. So what we have there is we have 64 A100 NVIDIA GPUs. So we have significant amount of compute power that we use for internal product development in AI. Also, we offer it as a HPC as a service, wherein different businesses or companies can rent out the hardware if they want to do their own modeling. And yes, something about me. So my name is Maykhel. I'm the head of the product development at AHB.ai. So my background mainly is I was a data scientist previously for about 4 years at Toshiba Corporation. Ever heard of Toshiba? HDD, SSDs, this kind of stuff. So I was mainly the lead data scientist for 4 years. So I was involved in data crunching, in dealing with big data analytics, identifying how our drive failed within the process. So may it be due to the induced by the process itself or due to the internal characteristic of the drive. So that's something that we are always identifying through big data analytics. And I just recently moved out to the UAE and able to join AHB.ai as a head of product development. Right, so for today's session, these are the contents that we're going to talk about. So we're going to talk about and we're going to define what is big data, what is big data analytics, and what are the types of big data analytics, and the characteristics of it, and perhaps the process of how to deal with big data, and what are the tools that we can use to actually explore or do big data analysis. And number 7, I think this is, I'm not really sure if you're going to be interested with this, but I'm going to talk a little bit more about data modeling and architecture type, mainly a high performance data architecture. And lastly, I'm going to talk about some of our use cases that are live projects that we have right now. I'm going to talk about what are the challenges that we face for these projects and how we actually overcome it to deliver to our clients. Right, so let's start with the most fundamental questions. So what is big data? Right, so big data is mainly a large amount of data, or large volume of data that are being generated from different types of sources. So these are, sources could be something like the internet, could be through sensors, could be through mobile applications or IoT technologies. So all of these sources generates large amount of data. And it comes with different forms as well, which I will talk about more in my slide. So it comes with being structured data, unstructured data, and being semi-structured data. So those are the different types of data that you can find within the big data domain. So it's also very important to, I think one of the key factors of big data, big data is not only about the size of the actual data, it's also about how you process the data, how you extract it from different data sources, how you store it, and how you actually play with it to deliver KPIs or to achieve specific goals for your client or for your organizations. And by the way, if you have questions, just feel free to interrupt me. Let's make this interactive. If you have questions, I'd be happy to answer them. So just a little something about the market in terms of global big data market. So by projection, by 2023, the market would be somewhere around 473 billion USD. So this is the projection. So as you can see, it's a very huge domain, right? Especially now that we are in mainly in AI domain, which is data is the food for any AI models out there, right? So actually, if you can see my laptop there, there's something written there that data eats model. So data is very important. That's the simple term. So just example of different organizations out there that are generating big data. So for example, Walmart handles more than 1 million customer transactions every hour. And Facebook handles 40 billion photos of its user base. So if you can only imagine this is a vast amount of data that needs to be processed, needs to be stored, and needs to be analyzed. And also the third use case, so for example, 10 years ago, decoding the human genome is originally took 10 years to process. Now, using different advanced tools like artificial intelligence or machine learning techniques, it can be done or it can be achieved in just 1 week. So that's also the power of the current technologies out there. Right, okay, so next question would be, what is big data analytics? So big data analytics is just playing with large volume of data. Like I said, it can come from different types of data, structured, unstructured, and semi-structured. It's basically extracting or turning, I would say, complex data into a sensible and actionable insights for your clients or for your organization. So it's basically dealing with different methodologies, which later on I will talk about. Okay, so on this slide, let's talk more about the different types of the data that you can get from big data analytics. So firstly, we have the structured data. So structured data, these are the types of data that are easily to deal with. So it follows a very specific format wherein, for example, if you have a CSV file or a spreadsheet files, so the format of the structured data comes with a common columns and rows, right? So that's how you deal with structured data, and how to analyze this data is very straightforward as well. So in terms of databases, we use what we call relatedness, RDBMS, or relatedness management system. So basically, you can use tools like PostgreSQL, MySQL. So those are the databases that can deal with structured data. And on the unstructured data side, so these are the type of data which are more complex to deal with, more complex to organize, and more complex to store in a database, right? So this could be audio files, could be video files, could be metadata from the internet. So on this one, to analyze unstructured data, we are mainly using advanced technologies like natural language processing, or NLPs, if you've heard of it. Also machine learning techniques or algorithms that can easily deal or find insights from unstructured data. So unstructured data can be stored from like Hadoop systems and can be extracted using Apache Sparks. So those are the different types of database that can deal with unstructured data. And lastly, we have the semi-structured data. So this one could be coming from data that are in the form of JSON files or XML files or HTML files from the internet. So when you actually do scraping or web scraping of the internet, let's say if you want to build an AI or large language model like ChatGPT, for example. So ChatGPT was trained on vast amount of data, billions and trillions of tokens from the internet. So once you do web scraping or common crawl, that they call it, you can't directly use this extracted data to feed to your model. So it needs to undergo data cleaning, data transformation, and before you can actually use it to train your large language model. So any questions so far? No? Okay. Now, okay, so let's talk more about the different characteristics of big data. So big data comes or can be categorized into three main categories, or this is what we call the 3 V's in terms of big data. So first of all, you have the volume. So any idea what my volume means in terms of big data? Yeah, exactly, that's right. So volume is basically the amount of data that are being generated. Like for example, if we're talking about, if we go back to on this page right here. So for example, Facebook handles 40 billion photos, so this could be a monthly basis, or it could be a weekly photos, or it could be entirely what's in database of Facebook. So volume is quantitative. So like for example, give you an example, like a Tesla car. Who here drives a Tesla car? Nobody? Ahmed? No, not you. Yeah, so if Tesla generates 5 terabytes, a single Tesla car generates 5 terabytes of data per day, right? So just imagine the volume of data if you have 500 Tesla cars that you are monitoring, right? So that's totally a lot, a massive data. And then velocity, on the other hand, is how fast the data are being generated. Let's say, for example, one user for Facebook generates, let's say, 5 terabytes of data per week, right? So that's how you can quantify the velocity of data. Or it could be like a process that generates 1,000 files per day, or it could be, you get my drift, right? So it's the velocity, it's how fast the data is generated. And then on the last one is the variety of the data. So like I mentioned, these are the different types of data that are being generated, unstructured, structured, and semi-structured. So those are the 3 different data that you can find on the big data. Right, so dealing with big data analytics. So I think this is the very standard process flow on how you can deal, or how you can start to deal with big data analytics. So first in the line is actually the case study and evaluation. So I mean, this is also something that we are following in terms of how we deal with our customers, how we understand the client needs, and how we establish goals to achieve those challenges. Okay, so first of all, you have the case study and evaluation. So in here, this involves interacting with your client or the end user that will use your application or your software that you will develop later on. So it's very important to understand all the problems that they're having within their organizations, right? So that's during this stage, you will establish a success criteria as well, or an objectives that you want to achieve later on when you actually start developing something for the client. And then second one is to understand what data is available and its sources. So this is something that we can advise to you if you start dealing with end customers or your clients. So don't forget to ask them if they are willing to provide data, right? Historical data, real-time data. So because that's very important. Because us as a company, we are an AI product development company. So data is very important to us because, I mean, we can always develop an AI system using synthetic data, but it's not going to make sense, right? It's not going to achieve anything. It's not going to solve anything. So we can always do that. But the real value is once the client provides you data, that's where actually all the values would come from, right? Because you are dealing with the actual data that are generated from their processes, from their organization. So it's very important to ask the client if they are willing to provide data. Okay.
She wants to.
I have a question.
Yeah.
If it's synthetic data, like
Sorry, say again.
so when you're talking, if it's synthetic data, wouldn't that be based off of the actual data that was used to provide
Yes.
the analysis? So wouldn't that also be okay outcome?
Yeah, in a sense, of course, if you are going to develop synthetic data, you need to follow at least the same format of a real data, right? Let's say you take on for example, if you have a structured data, you have the column headers and the first row of the input or the entries for each column. So using those, you can actually generate let's say billion rows or million rows of synthetic data, right? But what I'm saying is, if you actually want to find a pattern from within that data, that would be hard to find from synthetic data, right? Instead of using real data from the company, wherein you can actually, that you are solving a real problem, right? So whatever insights you can find there, it's viable and usable. Okay, of course, still on the second part, it's important to know the sources of this data because this data could come from different sources, like I said, could be from different systems that they have within the organization, or it could be external platforms that they're using. So it's important to understand the sources and actually the types of data. And once you establish this information, you will actually start dealing with the data now. So there would be like filtering of data, different data sources, different data types. So you need to kind of centralize this different data and store it in a centralized database perhaps, or to the appropriate databases that could accommodate these different data types. And after that, you will start data collection and extraction. So, like I said, how you can establish connection to these different data sources could be through APIs, could be web scraping, or they could just handle you the documents through a flash drive, right? Which we have one customer who actually gave us like data sets through a flash drive, which is very unusual, right? So after that, you need to aggregate this data. It's like combining all the data that you can combine, segregating the data with similar structures, and storing them to the databases that they need to be stored. And after you have aggregated the data, the next step would be to visualize what the data looks like. So in here you can use about the tools, so we're going to talk about that later. So in here, it's important to explore or do data engineering, wherein you kind of this specific process is, I would say, like a trial and error, right? You can concatenate or aggregate different columns from the data. So that's like the exploration of the data that you need to do, or a data scientist needs to do, or a data analyst needs to do. And then data analysis and exploration, right? So once you actually identify what are the possible components that you need to focus on during the visualization of data, you can further deep dive into the data analysis. So either you can do normalization of data, aggregation of data. You can do that on this space. And then final analysis, this is once you've actually extracted all the KPIs that you need. You're gonna prepare them in one place perhaps, then deliver them as a result. So result could be a form of charts, bar graph, pie charts. So those are different charts that you can use to actually provide insights to your client or organization. Any question on this part? Yes.
One question. What about how accurate is the data?
Right.
How challenging it is for you as a data analyst when you are going to the company? Because I think the source and how accurate the data also is a huge issue.
Yes. Yeah, of course, that would come from this part right here, filtering and data collection part. Because in this, on the back end, what is happening is you perform data cleaning, right? So you clean the data, you remove duplicates, you remove the specific characters that are irrelevant to your analysis. So that when the data analyst or the data scientist actually receives this data, it would be easier for them to understand the data without, let's say, if you work with something with missing values, I would say, or empty values within your data, it's very hard to come up with an insights out of that, because that might create what we call the outliers, right? So that might affect the linearity of your data. Yeah. So these are just some of the tools that you can actually use for big data analytics. So there are, I would say, thousands of tools that you can use aside from this one. So anyone from here who've actually used any of these tools? Which one have you used?
Tableau.
Tableau, okay. Any other one? Tableau, okay. There are other tools that we can use for platforms like Power BI, MS SQL, Spotfire. I'm not sure if you've used Spotfire. In Toshiba, we're using Spotfire. Yeah, so NoSQL database, it's a kind of a non-relational data management system, which again does not require any fixed scheme, and making them great for big, raw, and structured data. Then we have a Hadoop. So we have a Hadoop system, so we use this tool. It's an open source framework that can efficiently store and process big data sets, or either in clusters or as a single file. And we have the tool called MapReduce, so it's an essential component for Hadoop system. So if you've implemented Hadoop, you can use MapReduce for that, for more processing of the data. And we have the Yarn, or it stands for Yet Another Resource Negotiator. It's also another component of second generation Hadoop, and it's a cluster management technology that helps with job scheduling and resource management in the cluster. And Tableau, of course, some of you know it, it's like a software platform wherein you can just plug in your data, you can play with it, create your charts, pie charts, and select your KPIs, filter it, so you can use Tableau for that. And Spark is also another tool that you can use. And for me personally, I'd like to use R and Python, right? Because I'd like to go the hard way, right? Because Python and Tableau, it's like you're just gonna code, or you're gonna code it, you know, to define your codes, how to extract values from this. And there are also others, or what we call who I think I would take it as a question. Who still uses Excel to do data analysis? Excel files. You use Excel, right? That's actually I think if you want to become a data analyst or data scientist, you cannot go to that path without actually learning how to use Excel, because that's a very basic tools that you can use to do data analysis and data crunching, I would say. But of course, there's the challenges on using Excel. It's a really huge data, definitely you can't use Excel, right? So there are other options right here that you can use, especially if you're using Python. So you can implement directly a machine learning algorithm that could help you analyze the data, or if you're using R, the same thing. You can build a machine learning algorithm based on the Python. Right, so in here, first, what I want to say in this visualization is that how we can do data modeling and how we can build a high-performance data architecture to actually turn this rubbish into an actionable insight. So there's a process within that we're going to talk about later on. Right, so this is something that I read a few weeks ago, which is, I think, a really good illustration of how an effective data architecture looks like. So it's made by Dylan Anderson. So if you want to visit the article, yeah, you can get the link here. So in here, basically, it's we're talking about how we can map the enterprise level up to the very bottom with dealing with data, specific data levels as well. So if you're looking at this pyramid right here, the very first in the hierarchy is the business strategy. So like I said, especially if you are dealing with clients, it's very important to establish this business strategy internally and what your client wants as well. So both your strategy and the client should be aligned, so that later on, because that would be the like a guiding star to the remaining parts of the hierarchy. So once you actually establish that within your organization, you will then proceed with a data strategy, and here you will talk about more what strategy in terms of technology, in terms of processes you want to employ on this data strategy. And after that, you can talk more about the enterprise architecture. This is just making sure that all the technology people are aligned with the strategy as well, right? And you have the data and technology implementation. So this is where you build your actual data architecture. You identify the technology that is rightful for the objective, for the available data sets, for the available data sources. So that is where you implement those. And on the other end, we can see these are the different domains, architecture domains, which are also important to factor in when you are dealing with big data or data architecture in general. So I think the point being would be, if you're a data analyst or a data scientist, you don't really bother on this part, right? Because the important thing for you is you get access to the data, you can start working for it. So you don't really need to bother with this. But if you want to understand where the data came from, what are the processes that it underwent, and before it goes to you. So basically, different domains, you have the business architecture. So these are mainly just aligning organization's strategic goals and the business processes as well, and as well involving the different stakeholders that are part of this business. And the next part would be the technical architecture. So in here, it's talking about more the underlying technology infrastructure that supports an organization information system. So within your organizations, you might have different teams, okay? You might have a financial team, you might have a procurement team, you might have a product development team. So each of these different teams uses different platforms or softwares and they are dealing with their own data, right? So we need to make sure that we can capture all this data and we can actually align the architecture to actually deal with this data efficiently and securely as well. And then you have the actual data architecture. So in here, you can strategically manage and utilize the data assets that you have within the different parts of the organization and to actually drive the business goals that you want to achieve. And then application architecture, this is basically designing the individual software applications that different parts of the organization could use or could utilize. And in here, these are just the example of data components that you need to consider as well, like the architecture governance, data security, data principles if they have that, data regulations that they have or that they follow. So yeah. Any questions on this part? No? Okay. So another diagram which I think is very useful is to understand the real process, starting from extracting or identifying data sources to the data ingestion, storing it, then providing access, and eventually consuming the analytics that you have provided or that you have gained from the data. So first of all, we have the very first part of this architecture would be the data sources. Like I said, it's very important to identify the data sources that data is coming from. It could be from internal data tools, or this could be your proprietary data tools that you use within your organizations, or it could be an external data source. This could be a third-party platforms or softwares that you're using. So it's important to identify that because that would be important on the next stage, which is the data ingestion. So in here, again, like I said, different types of data goes into different types of, or undergoes different type of ingestion techniques, right? So you might also have, after you identify that and kind of like consolidated those data, it's now time to do the data storage and processing of this data. So you could either have like data lakes, different databases, data warehouses, or data lake houses. So you need to have this in place, ready for data transformation, right? So in this part, it's important that whatever data you can transform, I think, should be done during the processing. Right? So that later on, once you give access to your machine learning engineers, to your data scientists, data analysts on the serve and access part, because these are the resources that will consume the transformed data. Right? So for example, if I'm a data scientist and I want to do a sales forecasting tool, so I need my data to at least to be a structured format when I have rows and columns and everything aggregated and also consolidated. So that's important on this is data storage and processing part. And on the serve and access, so this is basically like giving access to your engineers or to data scientists or to different third-party softwares that are mining the data. So we have also here different types of data processing, like the operational data store. So these are the real-time or near real-time data sources which are consumed or used in a daily operational basis. And you have the analytical data store, or the ADS. So this is more to do with the historical data, which you can use later on. You can deal with it offline, that you can do in-depth analysis on those data. And so once you've given access to your ML and AI engineers, they can start providing or creating algorithms that are actually solving the objectives, or on the BI and analytics, you can provide charts for the insights or for the KPIs, and eventually analytics and consumption. You just give it to your boss. Boss, this is our projection for next month. This is our forecast for next month, and basically that would aid for the decision making of the business, right? And on the other part, on this part right here, it's also important to note that there should be a data governance or data management and security in place, where you need to make sure that the access is given to the right persons or to the right softwares. No external people could access your confidential data. I think my colleague Ahmed, also using his cell phone, could relate to this too much because he's our head of cybersecurity. So he deals with all the security aspects of dealing with data. Actually, before I can access to clients' data, I need to sign up for some tools, for some forms. Then Ahmed would provide me with access. making sure that I have the proper third-party tools in my laptop, like antivirus or other phishing attack tools that could help or make sure that this data that I am accessing is safe and there would be no leakage or anything. And down below, you have the different data architecture use cases as well, which I'm not really going to talk about. So as you can see, I think most of you would come to this part where you will deal with whatever data is given to you. But like I said, it's important to understand the process that your data went or underwent. Right? And okay, so in here, another very informative illustrations here. So if you're building data architecture implementation, right, so you should have like a success criteria. Like how can you measure that your data architecture is really effective? How can you make sure that it's secure? So these are the different aspects that we can consider while building data architecture implementation. So first of all, if you can see here the resource decisions, it's very important to hire data architects or those skilled to actually build the data pipeline for you. So on the data architect side, skills is not the only thing that you can consider on hiring data architects or data engineers, because data architects plays a crucial role, not only understanding the technical side of it, but also the strategic side of it, right? Because if you can see on this part right here, the data architect is the one who's actually building the gap or bridging the gap from the strategic to the technical technology. Meaning data architect would identify whatever technology is appropriate or necessary for the data architecture that he's building, as well as it should be aligned to the business strategic goals as well. And in here on the process side, you have the mixed modeling approach. So building data architectures, like I said, there could be different approach in terms of building data architecture, which is solely dependent on whatever data that you're dealing with. So it's important to have a different modeling approach, because one modeling approach might not work to all the data, right? So if you have a couple of modeling approach wherein it does a certain job for different data sources or different data types. So it's important to have that in place and actually have your data architects design that for you. And the last one is to have like a centralized function. Like I said, in the organization, it's important to make sure that all different departments using different systems should have like a centralized function so that you can ensure smooth operational within your organizations. Right, okay, so I think I just found this funny, I think. So, you know, dealing with data architecture is a very messy thing. It's a complex thing, right? So you can't afford having just one person who actually knows the ins and outs of the system, right? So like I said, it should be centralized and properly documented so that, you know, if these guys resign, the operation still continues, right? So that's one thing that you can consider as well. But it could be applied to different positions as well, right? It could be, you know, machine learning, if you've done the code, which are extremely important. So if other engineers can't read your code, that would be a problem as well, right? So it's making sure that all the processes are properly documented, all the tools are properly documented, all the codes are properly documented, so that if anything happens like this, there could be a seamless transition. You know, if you could just read the code seamlessly, just reading the documentation would be good. Okay, I think on this part, I would try to give you a real sample or use cases that we are having right now. So these are live projects that we have in our pipeline. So first example is we have a retailer client, one of the biggest in the UAE, who wants to actually implement AI within their organization. So let's say, for example, to the volume of data that are being generated. So a single store can generate about 1 terabyte of video footages. So these are CCTV footages. So that could be 1 terabyte. And I'm talking about one or a single camera only. So imagine if the store has, let's say, 50 cameras. So that's about 50 terabytes per day. So how you can actually make use of that. So what currently happening is they have this data, but they don't know what to do with the data they have. So I guess that's also the part of our value creation team. We have a value creation team in our company. So they're basically the one who's giving idea that using your data, these are the possible things that we can do based from your challenge statements or problem statements. These are the things that we can implement to solve or tick the box for these challenge statements. So, okay, what lies beneath? So, some of the things that they want to do is to understand the customer journey, like starting from the people or the customer enter the premise until they go to the store, get something, pay for it. So that's the overall journey that they want to map out and understand how they can improve it. Like for example, on the stocking side of it, like for example, we want to analyze the heat map of the store, where the aisle 1 has more heat map than the aisle 4, what's in the aisle 1 and what's not on the aisle 4, right? So they can do the platform management or the regioning of the aisles. So that's something that they want to do. And a very, I would say, a very unusual use case that they have is about the stuffing. So they've given us one use case wherein the owner itself, he wants to kind of measure the productivity of all the store managers within the stores. So for example, of course, you're paying store managers within the stores. They might not be doing their job. They might just be standing around using their cell phones, not talking to customers. So that's what they want to measure on this use case, wherein, for example, if I'm a store manager, if I'm talking to customer, assisting them with something, that could be measured as productivity, right? Where if I'm just using my cell phone, I'm just standing there doing nothing, that could be the opposite, which is the unproductive measurement. So they want to measure that as part of their use cases. And it could also be about the health and safety, wherein especially perhaps identifying the dirty spots within the stores, like if there are spilled water, or if there could a cart which is obstructing the area, so they want to see that as well. Now, like I said, the clients usually don't have the idea how to start. Like I said, they have the data, but they don't know how to start and make use of their whatever data they have. Okay, so I think one of the, so basically in this, they've given us about 700 gigabytes of worth of CCTV footages, and based on that, we've actually used about 20% of the 700 gigabytes just to come up with a POC, show them like 3 out of 20 use cases that they want, just to show the capability and what can be done on the data. So they actually liked it. Yeah, again, the challenges on this use case is about, the data is huge. That's the first thing. 700 gigabyte, you can't model that using conventional machines or your laptops, right? That's why we have the high performance compute data center at the park to actually help us process this video footage, train our AI model based on those videos or images, so that we can come up with a POC that actually solve this or check this use cases right here. And then the second example is a logistic company, also one of the biggest in the world, I would say. So basically, they want to do sales forecasting prediction models, right? So what's funny here, because currently, considering that they are one of the biggest logistic company, they are just using Excel file to actually forecast their sales on the next month. So they're using Excel formulas, right? They're loading data. It's kind of like it sounds funny, but it's actually happening, right? They have all this data right there, but they don't know how to do how to properly make an insights out of that. So actually, we created a deep learning model that can actually forecast the sales for the next month, for the next week, for the next day, using the data that they've given. So yeah, the challenges that they have, they're doing it manually. They're doing it tediously using Excel. So one lady is doing it, spending about 5 hours a day just to come up with a forecast, dealing with the data. Yeah, they don't even have any analytics platform at the moment. Yeah, so the data was small, many variables to consider. Yeah, okay. So in here, I think one of the mistakes that we did is kind of, we limited the amount of data that we asked. So for example, they have like 5 years or 10 years worth of data in the shelves, but we've only asked for a year worth of data, which is I think a mistake on our side. So I think the idea, if you're doing machine learning or AI, is that the more data that you have is the better, right? And also I think there goes the saying that garbage in, garbage out. So there's also the part of the data cleaning of the data. So I think the main point here is, if you can ask for more data, you should ask for it, right? If the client says, no, we can only give you the 5 years worth of data or 1 year worth of data, I think you can explain or you can fight for it that, we are making an AI model for you and we need this much data to actually train the model that could, solve your challenges. And what else do I have here?
What if the data they had before was not good enough in comparison to the data they have now? Like, for example, they changed their processes from 10 years ago. Changed their processes from 10 years ago until recently, until 5 years ago. So the data quality changed because of maybe chemical change or anything like that,
Yes.
or they knew that they needed to include this much information later on. So how would you deal with that?
Yeah, actually, this is a very good question because we're actually having almost a similar problem. Because like I said, we've only asked for a very specific sets of data, and then we started doing AI modeling for that, machine learning modeling for that. But later on, we found out that some of the very important data are missing within the main data that they've given us. So we started asking for more data that make the process complex and tedious. So like for example, to extract the date from the monthly data that they've given us, we need to get that from different types of data sets, wherein wherein if we just ask for all the data that they have, we might find that out more early in the process, right? So that we could have counter that. So on your question, this is very important as well. That's why going back on the identifying all the data types that they have, all the data sources that they have, it's always important to ask that questions, like all the data that they have, give the list, what this data do, what this data source do. So you need to have the list of that so that later on, once you actually do the modeling or the data analytics part of it, you can always come back to them that, okay, I might need this data, all this data perhaps. Yeah, I mean, there's a part wherein, like I think, are you asking for, if I have 20 columns, do I need to use all of that? Something like that? No, not necessarily, because you only need to identify the features or the variables that you need to actually solve the problems that they have. Let's say, for example, out of 20 columns or out of 20 variables, there's only 5 that are contributing to this KPIs that they want to see, right? So you need to drop the 15 so that in a sense, your process data would be smaller in the size. It would be easier to process later on. So that comes on the data cleaning, data exploration, and data analysis part.
What if there wasn't enough information in one of the columns?
Yeah, I guess that's
That you would need in order to
yeah, I guess that's the
wasn't logged or was it edit or something?
Actually, like I said, that's something that we are dealing with right now. Right? There are missing data. There are missing data types. There are missing data frames that we can't find. So it's actually where we're doing like a time series based modeling, deep learning models, where in time series it requires you to have like observation of daily transactions, daily patterns. So these specific dates is not available on mainly on our historical data. So the question for us is how we can efficiently build a model without this data. Although they've given us the other data sets that we can extract the dates out of that and merge it to our historical data. The problem is there were inconsistencies between this data, like if you are merging with one variable to another variable, there are lots of columns that doesn't have those entries. So in a sense, it's affecting the result that we're having. So again, going back to the identifying whatever data that they have, like I said, if you could ask for all the data, do it. If not, I think you can figure it out later on.
Yeah. So I mean, like if there were numerical data, for example, and there were a lot of missing values,
Right.
or let's say there weren't a lot of missing values, there are some.
Okay.
Would you do like an average?
Uh,
Or would you use the model to predict those empty or not available values?
Yeah, I get your point. So on that, if we're talking about just some minimal numbers, right? Perhaps you can do some techniques like interpolations, right? Where you're gonna fill in this missing values based from the known observations. This is from the previous transaction, previous dates, or the succeeding dates. There's also what we call the forward fill and the backward fill. Like for example, if you have a missing piece here, the model would understand whatever is the previous data, and then it will understand whatever is the past data as well, so that it can come up with the most possible substitutes, something like that. Sure. Yeah, I think. Yeah, there's more. Right. Right, so the example one, the retailer, I told you the challenge statements that they have and the use case that they have. Okay, so I can just skip this one. Right, so I guess the points to note for this session is that all data is not the same, not in a sense of the data types, but rather how the data needs to be processed, the uniqueness of the data. So those are different characteristics of the data, which, in a sense, you can't treat all the data the same way because they have their own ways to deal with them. And of course, developers and talents, you need to have the right amount or the right people to actually help you deal with this. Maybe the data engineers or data architects who build the pipeline, or maybe the machine ML engineers or the data scientists who deals with the data, or it could be the IT guys who actually provide you with the right infrastructure to actually you can host the data sets, or you can host the models that you're building. So these are just some of the points. Right, so I guess this is all from my session. So if you have questions, or if you think you want to work with us, right, in terms of your projects, you can contact us here. You can follow us on LinkedIn or website. You can follow me on my LinkedIn as well. You can connect with me. So that's all for today.
Questions?
Any questions? Any more questions?
No. I have a question. You can go back to the legal style.
This one?
The legal style.
What?
The legal. Yes.
This one? Yeah, okay.
I think it would be important for us.
Yeah, no, like I said, I think the main point that I want to convey here is just, if you're doing data modeling, architecture, if you're a database company, if your client is a database company, I think the idea is how you can actually turn this mess into an actionable insights, right? So whatever is in the back end is all this the architectures, the processes, the success criteria perhaps. So that's just basically the idea of this slide.
Questions? Yes. Yes. From the managerial point of view, imagine this morning I was with a firm, 500 employees. This was a family firm. And when I started asking questions, most of the decision making was based on the experience that few people had based on past experience. How this company can start developing a structure in order to use the data and to convert this data into an instrument that helps them to the strategy. You know what I mean? Mm-hmm. Yes, I don't know, when you are going to a customer, client for you, and you see that there is data all around, mm-hmm. but this data is how a manager is thinking about to convert this data into a structure is one that you explained here. It's how difficult it is for them and how difficult it is for you to convince them that there is a lot of potential there. You know what I mean, no?
Yeah, I kind of get what you mean. So, are you saying how we can come up with with a value, or
Show me the process that
that's it.
For example, this process is very clear that how you explain, you know. But if I am a CEO of the company, mm-hmm. This is my company, I said, okay, I have to start thinking about this in the future. Mm-hmm. Where to start? How to start?
Right.
I should start based on a problem that I have, mm-hmm. based, for example, to improve the machine working,
right.
to improve my customer service
right.
experience, or it should be more integral part.
Right.
How to think strategically in moving an organization into this from your perspective?
Right, so it's a very good question. So as our approach in the company as AHB, so like I mentioned, we have a team called Value Creation Team. So basically what they do is they speak with the customers or the client and actually identify what are the list of problem statements that they have. Right, like for example, if they want to improve any processes, if they want to convert a manual process into an automated one, we need to kind of list all those problem statements, and then perhaps gather as much information as we can, like what they want to see or what they want to achieve in the future. So like for example, if they want to have a software that can do all this, if they want to have an application that can perhaps do 50% of the overall challenge statement. So once we actually have a vision of that, or once we have a visual of what they want to see as an end product, perhaps what they want to be on the end product, then we start working backwards, right? Meaning working backwards. Once we know what they want to see, we identify, okay, based from all the available data that they have, how we can actually transform this data and come up with the KPIs that they want to see. Then the rest of the process would still remain the same. You have identified the data, you ingest, make a machine learning out of that, make the web GUI for make a mobile application, web application based on that. So I think the very first step is identifying the problem statements that they have, because you're not going to define that for your client. They need to give that for you.
That's excellent. I think it's a good point to start thinking about what is the statement, what they want to change, what they want to
yes.
improve, what they want to. It could be process, it could be customer, it could be. Another question is, in terms of the organization, what does it mean this moving into more data architecture and big data is how many or what kind of resources do I need really? Mm-hmm. To what extent I can outsource certain kind of services, mm-hmm. and what kind of resources do I have to have? Mm-hmm. For example, imagine Imagine that I have a capacity in my company to collect certain kind of data, but I don't want data analytics in my company inside because I don't have money to pay for them. This is possible to outsource
Right.
or not?
Yes, definitely.
You know what I mean?
Yes.
It's how expensive it could be this for an organization and how to think about what kind of resources are strategic to have inside
Right.
and or to.
Yes, this is a very good question once again, Dr. Rodrigo. I think few things here. I think as an organization, you need to know or to identify if you have the right resources to actually build what you want to achieve. Like if you want to build a data pipeline or data architecture that could handle all the data that you have, if you want to retain it internally, right? So you need to see if you have the right people within the company who can actually do it. Like if you have the data architects, if you have the solutions architect, if you have the data engineers within your company to actually do it. Or if not, I guess another question that you need to ask is, would you be willing to hire these right resources or right people to actually build this for you, again, internally? Or like you said, there are companies out there who can actually build this for you externally. All you need to do is inform them whatever data you have, what do you want to achieve, like all the data sources, all the non-functionality requirements, functionality requirements. So there are external companies who could definitely build up for you, create a centralized platform or an application for you wherein you can just give access to your employees. So I think those are the key factors that you need to identify if you have the internal capability to actually build it yourself, or you can just outsource it, right?
No more question? Yes.
Just to answer your question, so sometimes you want to think about the technical solution, so you want to offer a benefit to the client. So if you are talking about HR, business processes, finance processes, procurement processes, supply chain management, you don't want to say, I'm going to introduce Tableau for this process. You want to talk about the benefits of you analysing the data, or what insights that you gain from that data, which is actually information. So from this perspective, when we extract data from data, just say, so I'm the advisor to the company. So when we extract data, we want to do transformation, we transform that data into information. From the information, we can then apply models to the data to provide insights. We want to provide insights to the client and say, this is what your benefit is with this information. And you can now make an informed decision about your business processes to give you leverage to with your clients at the end. So rather than think about the technical data, you want to talk about the benefits of that information to the client.
Questions? Ideas?
Questions?
First of all, thank you for the presentation. Just to build on your question that Rodrigo has explained, certain industries have common problem statements all across the board. Some have unique competitive situations. And certain people within those industries have decades or maybe half a century of experience.
Right.
Is it possible, and it's not recorded, it's all there.
Yeah.
Is it possible to build an AI model based on a person's experience? For example, you want insight,
Yeah.
and you want to inform this decision, but it's based on someone else's experience that
Right.
is not recorded, or it's not an Excel sheet.
Right. Yes, it's a very good question. Yeah, I forgot to answer that from Dr. Rodrigo. So the sales forecasting project that we're doing, first of all, it's a sales domain, right? I'm not in sales domain. Nobody in our company is in sales domain. So what we do in terms of this project, which I forgot to mention, is we are working with domain experts. Domain expert could be someone from university who has vast amount of experience from certain domain, or it could be from the industry itself. So for this specific project, is our domain expert is someone who's actually doing the forecasting himself, right? So based on his expertise, he's basically guiding us on, like for example, if we have developed a first iteration of our model, these are the results. We'd go back to him and say, is this right? Is our output correct based on your expertise? If you say no, it's missing this, this, and that, we go back again to we look at again the data. We do more data exploration and do the remodeling. So these are kind of like an iteration. You do experimentation, you get a result. The result is wrong. You go back to experimentation. It's like a cycle, right? That you need to iterate fast on that cycle. So yes, to answer your question, this I would say experts, either within the company, they're experts of what they do as a whole, as a specific process that they do. You can always take their inputs and guide you in terms of your modeling algorithm to actually validate if your model's result is correct or not.
Just a small follow-up. So the fact that it's iterative makes a lot of sense.
Yeah.
But I'm considering that tech today makes this faster. What would you estimate is the time that you need to kind of have a relatively high, accurate insight from you based on this iterative process?
Right. I mean, if we're talking about, let's say, there are a few stages in this. Like if you're working towards developing a POC or a proof of concept, if you want to achieve like an MVP level, most viable product, or later that a fully functional product later on, right? So those are the three different stages, I would say. So typically for POC, long as they've given you access to data, so that would typically span from, I would say the safest would be 8 to 12 weeks to actually come up with a working POC, all right? And if you want to reach the MVP level, of course, there might be some, you might request more data from them so that you could increase the accuracy of your model, you can increase the performance of your model. So that would add like, another 4 to 6 weeks, right? So just to go back to the iteration process again. And of course, if you agree to some sort of, in terms of commercial agreement, that they want to proceed with full development of the product, so that would span from perhaps another 24 weeks or like 16 weeks perhaps.
Thank you.
Questions? Yes. Those here? Yes.
Back to the slide that was for the 3 weeks.
Oh, 3 weeks.
Because I thought of the question and then I forgot.
This one?
Yes.
This one? Structured data. Unstructured data, yeah. So, like I said, these are the types of like video, CCTV footages, audio, perhaps call. If you're working with call center, they perhaps would provide you with the voice recordings. So you can consider that as unstructured data. So these are the data that you can easily deal with, in a sense that these are videos, audios. This could be metadata, right? Unlike the structure. Right, yeah. Like for example, the retail use case that I mentioned. So they've given us 700 gigabytes worth of CCTV footages out of that. So basically what we did is we created a computer vision models that could actually solve the use cases that they have, like identifying the demography of the people entering the store. Like if it's a male kid, a female kid, a female teen, male teen, kind of like a demographic analysis. And understand where they go on the part of the store. So perhaps kids would go to the toy area, right? Or there are also certain analysis that you can do, we can do for that. Like for example, to identify perhaps the nationality of the people. Like for us, if you are, let's say, an Indian, you might go to the Indian part of the store. Right? If I'm a Filipino, I'd go to the Filipino part of the store. So those are the types that you can actually do from the video that provided to you. But the main thing, if you're dealing with video and you're doing computer vision models, is actually building the data sets. So that I think building a quality data set makes up about 80% of the overall product, because the rest of the algorithms just comes in. It's more to do with the data, like how we can identify the male teen. So we need to manually extract that from the video frames, build 10,000 data sets of that, right? I would say yes, especially comparing to the structured data, wherein you have everything almost ready, right? So unstructured data, there would be more process to do to transform this data into something that is acceptable to your AI model or your machine learning model. Sure.
No? Maybe it's time to let him go home and relax today. Thank you very much. It was
My pleasure. Thank you all. So on October 15th, so another one of my colleagues would be discussing more about the AI part of what we do. It's going to be here by October 15th, I said.
Yes. October 15th, we have artificial intelligence. How we can use this data
Yes.
in order to create information for the decision making. Thank you very much. We'll meet in class